Linear programming on Excel finance version. So in this question, we're going to do a portfolio allocation. Awesome. Okay, so it just means there's going to be a lot of different constraints, but they're not more complex necessarily, just more of it. We follow our three-step plan, always decision variables, objective function, and constraints, and then we work the details from that index. Okay. So we have a brokerage firm tasked with investing $500,000 for a new client. Ooh, constraint. The client has asked the broker to select promising stocks and bonds for investment subject to the following guidelines, more constraints. 20% in at least 20% in municipal bonds, at least 10% each in real estate and stock and pharmaceutical, at least 40% a combination of energy and domestic stocks, with each accounting for at least 15%. So lots of constraints so far, fairly straightforward. No more than 50% of the total amount invested in energy and automobile stocks in a combination of real estate and pharmaceutical company stock. Holy cow, a little more complicated, not impossible. That one we'll have to be very careful with. Subject to these constraints, the client's goal is to maximize, maximize projected return on investments. So it's kind of telling us what the objective function is. The broker has prepared a list of high quality financial instruments, and the following rates of return are listed there. And we want to select items for our portfolio. What are we selecting? Investments. And we're going to use that following the basic tools of linear programming, and then solve it on Excel. So we kind of get an idea of what is our decision variable, right? We're deciding on which of these stocks to invest. Okay, so we have a decision variable, and let's make M equals to the dollars. I abbreviated a little bit just because I only have so much space. Dollars invested in munis or municipals. Let's A equals to dollars invested in American Smart Car. G, dollars invested in Green Earth Energy. And P equals the dollars invested in Roslyn Pharmaceuticals. And last but not least, R is just the dollars invested in Realco, real estate. Okay. So there's our decision variables. We have 5 financial instruments that we're picking amongst. Okay, next step is our objective function, right? And we see we want to maximize return. So max the return. How do I calculate that return? Well, now I have rates of return: 5.3%, 8.8%, 4.9%, so on. I'm going to express those as decimals because I'm using them in a calculation, and that calculation is returning as its units amount of dollars. And so in order to find out how many dollars I earn off of purchasing City of Miami municipal bonds, I would go 0.053 times by however much I invested in those municipal bonds. So I get 0.053 times by M. That gives us our return on municipal bonds in dollars, and then plus 0.088 times by however much we have in American Auto, plus 0.049 times by however much we have in Green Earth Energy. Add to that the 0.084 invested in Roslyn Pharmaceuticals, and the 0.104 invested in Realco. So there's my objective function. Okay, so far not too bad. Right, a few more decision variables than what we've had so far, but nothing we can't handle. Constraints, well, those are going to get just a little bit more involved. And well, so I'm going to scroll back up to the beginning of the question. And so we have some constraints. First of all, we start off, we have $500,000 to invest. So we have a maximum number to invest. Okay. And I'm just writing these out in words just so I can fill out the details one at a time, which is a big problem. I don't want to get confused. At least 20% municipal bonds, so that's kind of a minimum in munis, so muni min. At least 10% each in real estate and pharmaceutical. So I have an R min, I have a pharmaceutical min. Then at least 40% a combination of energy and automobile stocks. So A plus G min, with each accounting for at least 15%. So I have an automobile min, and I have an energy min. Okay. So lots of constraints. But so far, I got it. No more than 50% of the total amount invested in energy on a combination of blah, 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 blah. Let's just call that a combo. Okay, that one is going to get special attention. That one sounds like it's a little on the trickier side. Okay, so we're going to talk about that a little bit more in a few seconds. So, maximum invested. Decision variables, M plus A plus G plus P plus R. All how much we invested. Okay. So, M plus A plus G plus P plus R, and that has to be less than or equal to 500,000. It's probably going to be equal to 500,000 only because the returns on each one of these financial instruments is all positive. No risk of loss anywhere, so we'll be fully invested. Next step is munis. So I have muni min, so that means the amount in municipals could be greater than or equal to some number. 20% of the total amount invested. Now, your gut says, okay, well, it's $100,000 because it's 20% of the 500,000. Well, two things. We're not 100% sure we're going to invest all $500,000. So that is a problem. We also want to be able to change our minds, let's say. Let's say it's not $500,000. Let's say it's $525,000. I don't want to do all this recoding stuff. I just want to change it in one place. So if I reference cells and variables rather than hard code amounts in, I've got that flexibility to do a little bit of what-if analysis. And that could be important. I mean, situations change. The investor maybe comes into a little bit extra money. Maybe the investor has a little bit of less money to invest, right? And we can just change it quickly and easily by just having to change it in one spot. So 20% of the total amount invested is 0.2. What's the total amount invested? Well, we just talked about that 2 seconds ago. That's the M plus the A plus the G plus the P plus the R. Okay. So it's relationships, but it's good, right? It's just math. We're just taking what we see in words, converting it into math symbols. R min means greater than or equal to at least 10%, 0.1 times by, again, that amount invested, which I'll just give it the dittos. P min, same kind of restriction. P greater than or equal to 10.1 times by, again, total amount invested. A plus G min, A plus G min meaning greater than or equal to 40%. Okay, 0.4, again, times by amount invested. A min greater than or equal to 15%, reading that out of the question, and again, total amount invested. Same thing with G min, greater than or equal to 0.15 times by total amount invested. Okay, so lots of constraints, but no individual constraint is trickier. The big twist is total amount invested, and how do we represent that mathematically if we don't want to say 500,000, because we want to keep that open. The combo now. The combo, we're going to look at the wording very, very carefully, and we see no more than No more than is like saying less than or equal to. Right? No more than 5. Okay? It could be 5, it could be 4, it cannot be 6. Okay? So no more than. No more than what? 50% of the total amount invested in energy and automobile. No more than 0.5 times the amount invested in energy, which for us is G, plus automobile, which is A. Okay, now what can be no more invested than that? In a combination of real estate and pharmaceutical. Pharmaceutical plus real estate. I just changed the order to just reflect how we've got it situated in the decision variables and how we have it stated in the objective function. Okay, so now we got all our obvious, easy for me to say obvious. We have all our more explicit constraints. Now we consider, do they have to be integer? Do they have to be integers? No. Right? Dollars could be a fraction of a dollar. That's what we call pennies and nickels and dimes and quarters and stuff. Okay, so it can be a fraction of a dollar. Okay, so I don't have to worry about the integers. Now, here's the more sophisticated. Do all these variables have to be non-negative? Ooh, more complicated issue here. They can be negative. In a finance context, I could have a negative amount of American smart car, and you're thinking, how the heck does that make any sense? Could have negative tables, couldn't have negative chairs. Why could I own a negative amount of stock? There's this thing in finance called short selling. Short selling is where I borrow the stock, shares of the stock from someone else. I sell it with the idea that I will buy those shares back later, and if I'm right, at a lower price, and then return the shares back to the entity or person from which I borrowed them. That's called short selling. So that would mean you'd own a negative amount of that stock, or a negative amount of those munis if that was possible. So in theory, not theory, in reasonable financial context, you could have a negative amount. Nothing in this question suggests that this particular investor is interested in short selling, so we will make an assumption and say they're going to be greater than or equal to 0. They're going to be non-negative. Okay. My guess is because so many of the stocks have a 15% or a 10% minimum, that other or 20, like the munis have to be 20% of invested, real estate has to be 10%, pharmaceuticals has to be 10%, auto has to be at least 15%, and green energy has to be at equals 15%. That even if we didn't have the non-negativity constraint, even if we were allowed to short sell, the investor has other restrictions that require him or her to invest a positive amount in each one of these instruments. So it's a good discussion issue, won't be a binding constraint in this particular case. Okay, so now we have our action plan, and we are all set to translate that into something that Excel can work with. So we're going to kind of keep with our standard convention. Each column represents a given variable. Let's move over. So, municipals or municipal. And then we have our automobile, American smart car. Make these columns a little bit wider. We have our energy, our Green Earth Energy, our Roslyn Pharmaceuticals, our Pharma, and Realco, or our real estate choice. Okay, those are all our 5 decision variables. We have our return. Now, I am going to keep the return as a percentage, and I'm going to show it on my Excel sheet here as a percentage. For no mathematical reason, I could easily keep it as a proportion. For a mathematician doesn't care if you say 5.3% or 0.053. However, if we're trying to represent this to a client, we want to keep the sheet in terms that is comfortable or that a client can relate to, and so we'll leave it as percentages. In order to do that properly, I need to highlight the 5 cells in which the percentages are going to go to. I go to the Home tab and I turn them into percents, okay? If I don't do that and I put 5.3 in there, my answer is going to be out by quite a bit. Okay, so now I can put in the 5.3, and excuse me, 8.8. Now you'll notice that the decimal is dropping off, and no need to panic. The decimal hasn't gone anywhere. It's just rounding. We'll make that adjustment in a sec here. We'll increase the number of decimals when we're done. 0.4. Okay, so we have to the 10th place. So I'm going to go up. I'm going to go over to the increase decimal, item, click item on the ribbon tab. I'm going to increase that to 1 decimal spot. The interest rates don't get into, the rates of return aren't any more detailed than 1 decimal. So now we're all set and everything is represented accurately. Okay. Next thing is I'm going to look at the dollars invested or amount invested, and that is we're deciding upon. So that means we're going to give that a little bit of a yellow color because we don't know what it is. We'll figure that out later. And in order to figure it out, we need to know what our return is. Okay. Give that a nice little green return. And we remember from past, that return is calculated by looking or by using the sum product function in Excel. So sum product. And we highlight the coefficients, comma, highlight the values of the decision variables, close the bracket, and then whenever we're ready, we click enter. Objective function, all set out. Now we work on these fun little constraints. So, constraints, we have a maximum invested. Okay. Right. We have a muni min. You could just say M min, but muni min sounds kind of cool. R min, P min, A plus G minimum, G min, and the combo. A tricky little combo. Okay. So maximum invested, we saw that it's M plus A plus G plus B plus R. It's like a cheer. Give me an M, give me an A, give me a G, B, R. Okay? But they all have a coefficient of 1 in front of them, right? So easy peasy, lemon squeezy. 1. We have the amount invested. It's a header here. Sorry. And we don't know what that is yet. Our symbology is we have less than or equal to $500,000. I punch in the less than, highlight it, underline it, push enter, center the symbol so I can see it nicely, and we have $500,000 to invest. Muni min, just a 1 in front of the M. It's a min, so it's going to be greater than or equal to. Greater than, highlight, underline, push enter, center this guy up, and 20% of how much we have invested. So equals to 0.2 times by, close the bracket. Or do I need to close the bracket? There is the question. Do I open the bracket and then add up all the amount invested? Or is there an easier way? Ooh, easier way, easier way. Well, I look and I say, when I go to calculate this, how much I actually invested is on the line just above it, right? Because remember, that invested column is how much you actually invest. I don't need any brackets. I just have to click that cell. Hey, I've gotten this calculation already. Why am I going to keep doing it over and over again? Especially since it appears in most of the calculations and most of the constraints. I don't want to be doing a whole lot of typing. I'm not that ambitious. I got things to do. Okay. And so, hey, look at that. got that down. Okay, so very cool. And I click OK. Click Enter. So put that little limit header on there. Forgot about that. Armin. Hey, where's my R? Under the R. 1. It's a greater than or equal to because it's a minimum. Greater than or equal to what? 10% of how much we invested. So equals to 0.1 times by how much do we invest? I gotta sell for that. Whoo, boy, you can see how I wouldn't want to be doing a whole lot of extra typing. P-min under the P. 1. Greater than or equal to as well. And greater than or equal to 0.1 times by. R7, or the cell which will contain how much we invest. A plus G. Oh, that's an A. Under an A1, G1. It's a min, so it's greater than or equal to. Greater than or equal to what? Look at my action plan. I see it's greater than or equal to 0.4 times by. How much do we invest? Hey, we reference that cell again. See how great it is to use cell referencing. It gives you so much more flexibility. And G-min under the G, under the O, 1. It's a min, so got to get a greater than symbol. Greater than what? 15%. I forgot a constraint. Equal to 0.15 times by how much is invested? R7. Awesome. I forgot my A min. Oh no. A min. Under the A1. It's a greater than or equal to. Boom. Equal to 0.15 times by how much we invested, which again is in that R7 cell. And now the combo. P plus R. Now that we did all the mathematical sweating on this, it's pretty easy from an Excel point of view. Less than or equal to, so I'm just going to go up to the cell with the less than or equal to. Control C. Click back down. Control V. Nice and easy. I like it. Nice and easy. Equals to 50% of the G plus A equals to 0.5 times by. Close the bracket. G plus A. Now we're all set. Once I push enter, I go into the solver box. So data, over to solver. Yes, I know that. Got some lingering stuff from previous solver. Set the objective, return, that's what we want to maximize. Changing the variable cells. Those are all my investment choices, subject to lots of constraints, which I will add. The first constraint being the amount invested, less than or equal to the limit. Keeping that just relative, just referencing the cell so I can change it later on. Add to that all these mins, which all have to be greater than or equal to all their respective limits. Add to that the combo, which is going to be less than or equal to its maximum. Not worrying about integers in this case. And then I click OK. And then I go, oh, I forgot to do the sum product. I'm doomed. I'm going to have to do it all over again. Ah, crap. Nah, I don't. Okay, so I go, I close it. I go back, I do the sum products. Equals to sum product. Right? Highlighting the coefficients, comma, the decision variables, which must be absolute referenced because it's the same amount invested for all the constraints. Close that bracket. Now I can copy that all the way down. Pull it all the way down. Boom. Good. Okay. I think I'm good now. Now I go to solver. Don't have to do any extra work. Oh, I got to click the solve button, of course. Click solve. No errors. I click OK. Boo! Ah! Yay! Got my invested. I'm going to put 100 grand in the minis. $191,666.67 in automobiles. $75,000 in energy. $50,000 in pharma. $83,333.33 in real estate. My return will be $38,708.30. I am going to invest all my money because the amount I actually invest is at my limit. I am going to invest only the minimum amount in municipals because it's that crappy return. I'm going to invest a little bit more in real estate. I am going to invest the minimum in pharmaceuticals. Interesting. I'm going to, the combo is not going to be the A plus G minimum, not going to be binding. The G min is binding. Okay, and again, probably driven by that kind of lower return than the rest. Okay, so I'm going to invest the minimum I could possibly can in green energy. The automobile, I'm going to invest a little bit more than the minimum. And the combo, I'm going to invest, that combo is going to be a binding constraint. Okay. And that is everything. Thank you very much for listening.